let us start. So do you have any questions from the previous class? Any questions? Great. So in that case, today we are going to start with the partial derivatives. Got it? So the partial derivatives. So we learned about the normal derivative, right? So if we take the simple function y is equal to f of x, and in this y is equal to f of x, so if you take the derivative of it, which essentially means that limit delta x tends to 0, f of x plus delta x minus f of x divided by delta x. So this is what we call as the derivative of y with respect to x, right? So this is how we define the normal derivative of any function y is equal to f of x, right? Now this is as if like it's a simple or single family wherein only two people are there. So wife and husband, and then so if wife got anger, then there will be a counter response from the husband as well. That means there is a change in the value of x. That means wife got anger here. So the husband also correspondingly he will be changing his behavior according to the anger what she got in. So the relation between these two, that's what we defined as the derivative when for a minor change in the value of x, the corresponding change in the value of y. So this ratio we take it for an accuracy purpose as delta x tending to 0. Now the partial derivative is nothing but a little extension to that. So take a joint family where there are multiple people are there. Suppose if I have a random function, so that is f of x comma y comma z. Now in that, right, so there are multiple people that got involved. Suppose if I call this as w, then this w, there will be a change according to the behavior of this particular variable, or there might be a change according to the variation in the value of y. There might be a change in the value of w according to the change in the z. So this is as if like, so if you take the derivative, that is dou w by dou x is nothing but, so the change in the value of x alone, x plus delta x comma y comma z minus f of x comma y comma z divided by delta x, limit delta x tending to 0. So here this is how a partial derivative is defined, which essentially means that the main difference between these two is here also there is a value change in the x, and here also there is a value change in the value of x, right? But the difference is, this is like, suppose you are trying to scold your brother in presence of your wife, then obviously the way you deliver your anger will be completely different when your brother is alone, correct or not? So that's what is the major difference between these two. So here only two people are there, so your brother and you are there and you are scolding your brother, so the response will be completely different. But when all the members of the family, maybe your wife or maybe your one more brother or maybe your mother or father, everybody is there, in the presence of everybody you are trying to scold one person. So there the complete response given by this person to this person is completely different. So as if like if there are no other people, the response is completely different. So here actually, though you wanted to scold to the 100% extent, you will not scold because everybody else is present. So you are delivering your anger to some extent only. That's why you are partially delivering there. So that's what we call as the partial derivative. Got it or not? So this is how we define the partial derivative is nothing but dou w by dou x. That is, this is only the partial. When there is a presence of y and z, you are trying to change the value of x, correspondingly there will be a change in the value of w. So this is the only value that got subjected to the change. So this is what we call as dou w by dou x. It's not dy by dx or dw by dx. So d is different from dou. So dou is nothing but the partial. That means when presence of all other variables, there will be a change in the value of 1. Correspondingly, the function value is going to be changed. So that is the major difference. So this is read as dou. Got it? So dou w by dou x. And here dy by dx. Similarly, dou w by dou y can be written as, so this is limit delta y tending to 0, f of x comma y plus delta y comma z minus f of x comma y comma z divided by delta y. So this is defined as the partial derivative of w with respect to y. Got it or not? Understood the concept? Right? So I hope it is clear to everybody. So this is the simple difference. So this is the normal derivative and this is the partial derivative. Now coming to the applications point of view, now in our physics or engineering problems, whatever you are going to deal with, right? So 90% of the cases are only the partial derivatives. 90% of the cases, because in any physical process or in any chemical process, the variables that are involved are more than one. So that's why if there are multiple variables are present, if you wanted to study the change of one variable when there are multiple variables that are present in that process, so in such cases you will be using only the partial derivatives. Now 99% of the engineering problems are such kind of cases only. Very rarely we will be dealing with only one variable change with respect to the other. So that is the normal derivative. That's why all our physical problems will be treated with only the partial derivatives. These are the practical examples for us. Got it? So we have to study this, right? Okay. Now this is quite simpler than the normal derivative to do the derivatives, because when you are doing the partial derivative, treat that everything else is constant. So you are trying to change only one variable. That means rest of the variables you can treat as if like it is a normal plain constant. So that's why the process of derivative is very, very simpler for us. Got it? So we'll solve some problems based on this. Then we'll try to discuss the other concepts that are involved in the partial derivative. So I hope you noted down this. Great. I'll give you a simpler one first. Find the first and second partial derivatives of, find the first and second partial derivatives of z is equal to x cube plus y cube minus 3s. Z is equal to x cube plus y cube minus 3axy. Can you find out dou z by dou x, comma dou z by dou y, and dou square z by dou x square, and dou square z by dou y square, and dou square z by dou x dou y, and dou square z by dou y dou x. Can you find out? These are straightforward and simpler, you might have done at engineering. Yeah. Can you solve it now? Anybody got it? Yeah. So this is straightforward and simple. I don't think I need to do that. So just for the sake of convenience, I'll just do it to some extent. Dou z by dou x is nothing but treating entire y as constant, a as constant. There is only one variable called x. So that is the derivative of x cube is 3x square minus 3a into, so x you are doing the derivative, so 3ay will be left over. So this is dou z by dou x. Now dou square z by dou x square. So dou square z by dou x square is nothing but, so this is 6x. So you are doing the derivative with respect to x. So hence you can treat that as 0 because a and y both are constants for us. Similarly, dou square z by dou x dou y. So that means you have done the derivative with respect to x first, and then you are doing the same function derivative with respect to y. So this is minus and then 3a. So this is minus 3a is the answer. So this is how you will be doing the derivatives, right? So here, if you notice, dou square z by dou x dou y is always equal to dou square z by dou y dou x. So that's why you will calculate one and then you can interpret it as if like it is interchanging. Got it? So it will always be the same. Clear? Note down one more. U is equal to x square. If U is equal to x square tan inverse of y by x minus y square tan inverse of x by y. So if U is equal to x square tan inverse y by x minus y square tan inverse x by y, show that dou square u by dou x dou y is equal to x square minus y square divided by x square plus y square, and dou square u by dou x dou y is equal to dou square u by dou y dou x. Can you solve this? Anybody got the answer for this? Yeah. Any more? Yeah. So I hope I don't need to do this. So these derivatives or the partial derivatives are quite simpler to do. Okay. Note down one more. If u is equal to x square plus y square plus z square, x square plus y square plus z square whole power minus 1 by 2. Prove that dou square u by dou x square plus dou square u by dou y square plus dou square u by dou z square is equal to 0. So this is nothing but the Laplace equation in 3 dimension. Got it? So this is del square u equal to 0 in 3D. Now try to prove this. Anybody else? So 2 people got it. Any more? Okay, so let me solve this. See this, here u is equal to 1 by x square plus y square plus z square whole power 1 by 2, because power minus 1 by 2 is there. Now if I square it on either side, then this will be u square is equal to 1 by x square plus y square plus z square, implies x square plus y square plus z square is equal to 1 by u square. Now if you take the derivative with respect to x on either sides, then this will be 2x is equal to, so this is u power minus 2, that is minus 2 into u power minus 3, so into dou u by dou x. So this 2 will cancel, then minus x is equal to 1 by u cube into dou u by dou x. Similarly, if you do the derivative again, this will be minus 1 is equal to 1 by u cube into dou square u by dou x square plus dou u by dou x into 1 by u cube derivative will be minus 3 into u power 4 in the denominator, and then dou u by dou x square, right? So this is dou square u by dou x square. This is the process we can do it. Now here, exactly in the similar manner, minus 1 is nothing but 1 by u cube into dou square u by dou y square plus dou u by dou y whole square into minus 3 by u power 4. Similarly, minus 1 is equal to 1 by u cube dou square u by dou z square plus dou u by dou x dou z whole square into minus 3 by u power 4. Now if you add all these things together, so you will get the Laplace equation at this point with a common factor of 1 by u cube, and here minus 3 by u power 4 will be common, and dou u by dou x and dou u by dou y and dou u by dou z, square it and add it, and so dou u by dou x is nothing but this is x into u cube minus of this will be dou u by dou x. Now if you square it on either sides, this will be the square. So if you square it and simplify it, finally it will lead to 0. Got it? Understood or not? Any questions on this? Yeah, great. Note down one more. If u is equal to log of x cube plus y cube plus z cube minus 3xyz, so that dou by dou x plus dou by dou y plus dou by dou z whole square of u is equal to minus 9 by x plus y plus z whole square. Can you prove this? So this is dou by dou x, dou by dou y and dou by dou z whole square. This can be further written as, I hope you understood this, dou by dou x plus dou by dou y plus dou by dou z of, so dou u by dou x plus dou u by dou y plus dou u by dou z. So this is how actually you can write this. So this is a shorter way of writing this. Clear? Yeah. So can you solve this? So 2 people got it. I think so. Others, what is the status? Done? Okay. So I am getting response from only 3 people. What about others? Okay. Anybody else? Bharati, so you want to solve or you want me to solve? Anybody else want me to solve or you want to try? Yeah. Okay, great. So I'm going to solve it for you. See this here. This is the function u is equal to log of x cube plus y cube plus z cube minus 3xyz. Now here, to make it simpler, what I will do is I'll take this log to this side. So suppose if y is equal to log x base e, then this will be e power y is equal to x. So this is the logarithm form and this is the index form, but both are one and the same, expressed in a different manner, right? So exactly in the similar manner, so if you take this as base e, then e power u can be written as x cube plus y cube plus z cube minus 3xyz. So this is how you can write the function. So both the functions are one and the same. This is the logarithm form and this is the index form. Clear? Is this clear to everybody? Yeah. So once you get this, then you take the derivative with respect to x. So because he asked us to find out dou u by dou x, dou u by dou y and dou u by dou z, and for that you need to take the derivative with respect to x, y, z again. So we'll take one first, dou u by dou x. Then if you take the derivative with respect to x on either sides, this will be e power u into dou u by dou x is equal to 3x square minus 3yz. Similarly, e power u into dou u by dou y is equal to 3y square minus 3xz. E power u into dou u by dou z is equal to 3z square minus 3xy. Now if you add all the three things together, e power u into dou u by dou x plus dou u by dou y plus dou u by dou z is equal to, so 3 you can take it out. Then what is left over is x square plus y square plus z square minus xy minus yz minus zx. Got it? So this is how you can write it. Now once you write in this format, then e power u is nothing but x cube plus y cube plus z cube minus 3xyz. But if you factorize this, if you remember, this is x plus y plus z times x square plus y square plus z square minus xy minus yz minus zx. So this is how you can factorize it. If you want, you can multiply these two, you are going to get this. Got it? Now exactly the same factor is present here. So if you take this e power u to the other side, then this will be dou u by dou x sigma, if I keep it rather than writing every time. So this will be 3 times of x square plus y square plus z square minus xy minus yz minus zx divided by x plus y plus z into x square plus y square plus z square minus xy minus yz minus zx. Now you can cancel these two. So what is left over is 3 by x plus y plus z. So that is dou u by dou x, dou u by dou x plus dou u by dou y plus dou u by dou z is equal to 3 by x plus y plus z. And then, so you need to again do the differentiation with the sum of dou by dou x, dou by dou y and dou by dou z. Now if you take one, I take only dou by dou x, then this will be, I call this function as v, let us say, then it will be dou v by dou x is nothing but the derivative of this. This is minus 3 by x plus y plus z whole square. And similarly, dou v by dou y is again minus 3 by x plus y plus z whole square. Similarly, dou v by dou z is equal to minus 3 by x plus y plus z whole square. Now, the sum of all these things, that is dou v by dou x plus dou v by dou y plus dou v by dou z is equal to minus 3 minus 3 minus 3 minus 9 divided by x plus y plus z whole square, where v is nothing but dou u by dou x plus dou u by dou y plus dou u by dou z. That means dou by dou x plus dou by dou y plus dou by dou z of square of u is equal to minus 9 by x plus y plus z whole square. Clear? So any questions on this? So here actually you need to remember that this can be divided into this format. That is the only thing here. If u is equal to x power y, x power y, show that dou square u by dou x square dou y. So dou cube u by dou x square dou y is equal to dou cube by dou x dou y dou x. Dou x dou y dou x. Now only thing is he changed the order of differentiation. So here the function is derivated with respect to x twice and then with y. Here he derivated with respect to x and then y and then x again, right? So the order actually he little changed. Now he asked us to prove that this is valid. Can you solve this? This should be easier. Not even a single person got the answer for this. Viren got it. So anybody else? I'm going to solve it anyway. But I'm expecting you to solve. At least I'll give you a hint. You try to solve it. So I think you should be knowing that. So y is equal to a power x. Then the derivative will be, so dy by dx is nothing but a power x log a. I hope everybody is aware of this. Similarly, y is equal to x power a. In that case, dy by dx will be a into x power a minus 1. So these are the only two rules that are played with this. That's it. Now which one you have to treat as constant, which one you have to treat as variable, that depends on the selection of the derivative with respect to x or with respect to y. So that is the only thing. Now you should be able to solve it. Now I will give you 5 minutes more to try to solve on your own now. After that, anyway I am going to solve it. Here. So use this trick. So with respect to what you are trying to do the derivative. Now u is equal to x power y. If you take dou u by dou x, then x is the variable here and y is a constant. So that means y into x power y minus 1, you are going to get it. Suppose if you want to calculate dou u by dou y, then x is a constant, y is a variable. Then x power y into, so this is a power x into log a, x power y into log x. That will be the derivative with respect to y. Got it? Now you give it one more try, then I am going to take it up. Okay, so let me try this. See this, here u is equal to x power y. Now we take the derivative with respect to y first. Then dou u by dou y is nothing but doing the derivative with respect to y. So that is a power x format. Then a power x into log a. That is x power y into log x. So this is dou u by dou y. So this log is base e. I hope everybody is aware. Then you take the derivative with respect to x. So dou square u by dou x dou y. And this will be doing the derivative with respect to x. So this will be x power y into derivative of this will be 1 by x plus log x into, so derivative of x power y will be y into x power y minus 1. So this is x power y minus 1 plus x power y minus 1 into y into log of x. So if you take x power y minus 1 common, then this will be 1 plus y log x, right? So this is dou square u by dou x dou y. Now if you take the one more derivative, that is dou square u by dou x square dou y, and this will be dou by dou x of this entire function x into y, so x y power minus 1 into 1 plus y log x. Now we will just keep this as it is for now. Then we will try to correlate it, because at the end both are with respect to dou x. So you can avoid doing the derivative at the end, and then you can try to equate dou by dou x of whatever is coming inside should be exactly same as dou by dou x of the other side. Got it or not? So this is as if like dou by dou x of dou square u by dou x dou y, and this I can equate as dou by dou x of dou square u by dou y dou x. So this is how you can prove that. So this is the principle what we are going to use it here. Got it? If you want to do it, you can still do that and prove it. That's not a big deal. Got it or not? So rather than doing all those things, we are stopping here itself, because there is an equivalence whatever is there inside. So we found one part, that is dou square u by dou x dou y. Got it? Now dou square u by dou y dou x we are going to do it. Got it? So then dou by dou x, dou u by dou x is equal to, so the derivative of this with respect to x will be y into x power y minus 1 is the derivative. Then dou square u by dou x dou y. So this will be doing the derivative with respect to y. So this is y into, so x power y minus 1 into log x plus x power y minus 1 into, so you are doing the derivative with respect to y. So y and then x power y minus 1. So this is dou u by dou x is equal to, so y into x power y minus 1. Dou square u by dou y dou x will be, so this is, you are doing the derivative with respect to y. So then y into derivative of this with respect to y. So then it will be x power y minus 1 into log x. And then by taking this as the multiplication x power y minus 1, so derivative of y will be 1. So if you take x power y minus 1 as common, then this will be 1 plus y log x. And this will be exactly same as this one. Now if you want to take one more derivative, dou cube u by dou x, dou y, dou x, then this will be dou by dou x of, this will be x power y minus 1 into 1 plus y log x. So both are one and the same. Hence the answer. Clear? Got it? Any questions on this? Any questions? I hope everybody got the answer for this now. Okay. See this. If you try to equate it here, you don't need to solve fully because this is known. Got it, Anjali? One last question. Note down this. If x square by a square plus u plus y square by b square plus u plus z square by c square plus u is equal to 1. Prove that. Dou u by dou x whole square plus dou u by dou y whole square plus dou u by dou z whole square is equal to 2 times of x dou u by dou x plus y dou u by dou y plus z dou u by dou z. So can you prove this? Yeah. Can you prove this? So here u may be a function of x comma y comma z. So that you have to be aware. A, B, C are the constants. Now you solve it. Okay, so let me solve this. See this here. This can be written as x square into a square plus u power minus 1 plus y square into b square plus u power minus 1 plus z square into c square plus u whole power minus 1 is equal to 1. Now, if you take the derivative on either sides, then this will be uv formula because u is a function of x and x is a function of x. So, if you take the derivative with respect to x, then this will be 2x into a square plus u power minus 1 plus and then x square. So, x square into derivative of a square plus u whole power minus 1. So, n into x power n minus 1. So, n is minus 1. So, this is a square plus u whole power minus 2. So, plus, so y square into, so derivative of this with respect to x, then this will be y square, so this will become minus and then b square plus u whole power minus 2 into dou u by dou x. Yeah. So here also dou u by dou x is there. Yeah. And then minus z square into c square plus u whole power minus 2 into dou u by dou x is equal to 0. Or this can be written as 2x divided by a square plus u is equal to x square divided by a square plus u whole square plus y square by b square plus u whole square plus z square divided by c square plus u whole square into dou u by dou x. Got it? I hope you understood this. Everybody? Right? So once you understand this, now exactly in the similar manner, so 2y by v square plus u should be equal to the same thing repeated with dou u by dou y. So I call this as u or v. I'll just call as v dou u by dou x, where this entire thing is called as v. And then v dou u by dou x. Exactly in the similar manner, 2y by b square plus u can be written as v dou u by dou y. Similarly, 2z divided by b square plus u, c square plus u can be written as v dou u by dou z. Now, what you need to prove is dou u by dou x whole square, dou u by dou y whole square, and dou u by dou z whole square. Now, if you want to prove that, then you square all the things and add it. Then the right side will become v square into dou u by dou x whole square plus dou u by dou y whole square plus dou u by dou z whole square. So that is on the right side, and the left side will be, so this will be squared. So here this will be 4 times of x square. So this is x square by a square plus u whole square plus y square by b square plus u whole square plus z square by c square plus u whole square. Right? Now, this is essentially what we treated as a v. So, 4v, so this can be treated as 4v is equal to v square times of LHS. And this v will cancel, then LHS will be 4 by v. So, this entire part became 4 by v. Got it? With respect to x only we are doing. So this actually with respect to x we have done, and then the same thing interpreted for with respect to y and for the with respect to z also. Then I squared all the 3 equations and added it together so that I can get the LHS part of it. And this is coming out to be 4 by v, where v is this entire function. Clear, Surabhi? Got it? Yeah. So any questions till now? Okay. Fine. So then actually on the RHS is nothing but dou u by dou x you need to multiply with x, and dou u by dou y you need to multiply with y, and dou u by dou z you need to multiply with z. So here dou u by dou x is coming out to be, so I'll just write this as 2x divided by v times of a square plus u. So this is nothing but dou u by dou x. Now if I multiply on either sides with x, then this will be x square. Got it? Now exactly in the similar manner, you multiply with again with 2, then this will become 4. So 4x square divided by a square plus u into v. Similarly, add y dou u by dou y. So y dou u by dou y. So this will become 4y square divided by v times of a, so b square plus u. Similarly, z, and then add up all these things together, you are going to get again 4 by v. So this is what we need to prove. So LHS is equal to RHS. Clear? Understood or not? Yeah. So don't get confused here actually. So 4 by v is out, and whatever is left over is x square by a square plus u, y square by b square plus u, and z square by c square plus u, and all those things together. This is the kind of equation you are going to get it. This you have to treat as one. So finally 4 by V into 1 you are going to get for the RHS. So that's why this will be 4 by V. Clear? I don't have any confusions in this. Do you have any confusions on this? Great. So this is about the partial differentiation, but we have got other things in the partial differentiation, like how to treat the homogeneous equation, and that we treat as a special case to solve complex differentiation, partial differentiation in a simpler manner. That is one method what we need to discuss. And one more is the polar coordinates partial derivatives. So those are the things actually I'm going to take it up in the next class. Clear? Any questions? See this. So we cannot guess that way. So obviously there is a weightage for partial differentiation also. Especially these questions are going to be asked in the question number 1 or question number 5. So wherein this kind of questions can be straight away asked. So this is the kind of models actually you can expect. This is a little bit complex model. So in UPSC, as a blind rule, what you need to remember is whichever is tough, that is going to be asked. So there are certain areas where we feel a little bit of vagueness in the understanding of concepts, and those are the areas UPSC will focus. Got it? Suppose if you read entire calculus, there are certain areas like two-dimensional limits and continuity and differentiability, or three-dimensional. Now there actually there will be a little bit of vagueness to find out the continuity and differentiability, but UPSC will definitely focus in that area. Got it? So those are the areas actually where you feel a little bit of vagueness, you can expect the questions from there. But all these things are actually, so for the sake of completeness, we are discussing each and every aspect so that we don't miss anything on the table. Clear? So we don't know, right? So he may ask or he may not ask, but the possibility of asking the questions where there is a vagueness. But these are also can be asked, but rarely it will be asked. But sometimes it was asked. Got it? So that's why for UPSC, the methodology of preparation will be you have to target 100% preparation without leaving anything, with at least even a single word you shouldn't be leaving in the entire syllabus what was listed there. So that's why you have to be thorough with all the aspects. So though it is easier or tougher, I strongly suggest that you go through each and every aspect in the syllabus and you understand the methodology behind it, and then try to be master in those aspects, especially focus the vagueness areas. Got it? Yeah. So that's why actually as an institute, we have to cover 100% of the syllabus. In that, whether it is important or not, I am going to cover it in detail. Okay, yeah. So thank you. Good night.